like surface creation in a little bit more detail. I'm not sure if everybody had enough time to check that out or if you were aware that that was on there. I'm interested in maybe rehashing that very briefly. This is just very briefly going to look at lofts, sweeps, different types of dynamic surface creation. And we can talk about the different ways to do that, and we can dwell on one particular operation if it's more useful. But just going to get rid of whatever this menu is here. Okay, so everybody's in RHINO. We should have, just for the sake of right now, let's have our kind of standard menus up. On the right, let's keep our display layers and properties menus tabs open. You can keep the help tab if you want, that's fine. So let's create a surface in a few different ways. And again, this is a little bit of a rehash of the tutorial I posted, but I think while we're doing it in person, we can troubleshoot some things more specifically than I did on the video. So the first thing I want to do is, I think we looked at this in the class together as well, but a very simple way to create a surface, an unconventional surface using curves, is a loft. So let's go ahead and just draw, for the sake of the example here, let's draw a curve on our C-plane in perspective. I'm just holding shift as I kind of work through a line that is not straight, just to give us some dynamism to the eventual surface. Now, if I were to copy this up, copy this vertically, we can also put our gumball on if we wanted to for a little easier navigation of the shape. Again, it's kind of up to you. I tend to work without it, but in some of these simple surface and RHINO commands, it's useful to have on. So we can go either way with it. But I'm going to copy this vertically, setting my vertical constraint in the copy command at the beginning of it. I'll just copy that up 10 feet. And we should be our units should be in inches, large inches. If you're not, you can switch that. So now what I want to do for here, just for visual clarity, I am going to turn gumball off. I'm going to move the control points on this surface around a little bit. So points on, let's just turn our points on a second so that we can mess around with this. So I'm going to slide this point this way. Let's move this point here. This just to illustrate the point of the surface creation. So now we basically have two lines that have the same number of control points, just at different points in space. So if we were to loft this line, type loft, and select these 2 points, it's going to attempt to extrapolate a curve through, or I'm sorry, a surface through this point. And you can already see there's some issues with this one. Firstly, let's cancel this real quick. I just want to put my shaded viewport on so that we can see the loft line work when it comes up. So let's type loft again. Select these 2 lines. All right, so there we can see it's twisted. So basically what this is this gives you, the loft command gives you the ability to align the curves in the command before you click OK. So if I click align curves, you can see that for whatever reason it's associating this endpoint with this endpoint and this one with this one. So it's it's flipping it, which is not correct. So if I simply left click on one of these points, it'll switch it to the other side. So what it's done is it's basically just reassociated this edge with the other nearest edge so that now I can get what I was intending, the kind of straight extrusion of surface. So now I could click enter to finish the command, or rather to complete the alignment subcommand of that. I'm still in the loft command here. I still have this box open. So there's a couple different ways that I can extrude the surface as well. The normal is the default. You can extrude it as a loose surface. When you only have 2 curves defining your loft, this is likely not going to be as indicative of what's happening. And the same thing goes for the tight extrusion, because it's truly just finding the points between 2 lines. When we start to operate with multiple lines, those commands will be more useful, and we'll look at those. Straight sections. Also, I think most of these are going to be activated a little bit more when we have multiple lines that we're extruding through. So for now, I'm actually going to just ignore developable and uniform, and we'll stay on normal. We'll click OK. Okay. So just for the sake of the exercise here, I'm just going to move this off to the side. Let's just move it like 50 feet away. Just keep it over there. All right. So now I still have these two curves. I could, to illustrate the dynamism of the loft command, let's say that I copy another one of these curves up. Let's copy it up 20 feet. Okay. And then let's say I rotate this. Oops. And we'll move it back in space a little bit just so that we have three different curves going on. So now if I type the loft command, and this is important, the order of the loft curve selection is important. So I typed loft. I've now chosen 1, 2, 3. It's also twisting these. So again, I have to go into my align tool and just simply reorient both of those until they're all lined up. So if I were to have, and you can see that what it's doing here with the normal loft is it's finding the smoothest, but also still as tight as possible point between the three curves that are its baseline, and it's still actually going through, the surface itself still goes through each point of these curves with the normal extrusion. So let me complete my align point here. If I were to go to loose and then preview, notice that it's now it's still, the profile shape at the top and bottom is the same as the line, but the middle line now has become basically a reference point for how this extrudes. So when it's loose, it's using this as a loose framework around which that line extrudes. If I were to do tight, the opposite's going to happen. It's going to be it's pretty close to the normal one in that case. You can see there's not much of a difference. In that particular case, partially because there's three lines, partially because those lines are not that complicated, the tight and the normal extrusion in this case are pretty close. But you can see again, like it's attempting to really stay close to the profile of each of these lines. Ultimately, it's kind of creating a surface that's not quite as smooth and nice looking as the loose one, but it also just very clearly does not hit all these points. So if you wanted the accuracy of hitting each point on that line, you'd need to use the loft, or the normal loft or the tight loft. Another aspect of this is straight sections. So now that I have two different expanses of lines, if I type this, basically what this is doing is it's saying, okay, I'm lofting to this point, to the first line, from first line to second line. I'm making sure that there's sort of full accuracy between these two sets of lines. And then I'm basically lofting again from that line to that line. So what you get is kind of a faceted situation where it actually has a ridge attached to it, which again, depending on what you're trying to do, can be useful. Maybe there's a facade that has a sequence of bays that are oriented or sized differently, and you need that break point to express structure or something else. In the case of this, because it's an abstract shape, we'll just keep it as normal. And again, we can see the preview. We'll click OK. I'm going to move that one as well. We'll move that 60 feet. Okay. So another aspect of this that we can look at here, if I were, like I mentioned before, the order of the curve selection is important. If I were to select loft, and then I was to say to choose this line, then this line, then this line, rather than 1, 2, 3 all the way up, it's going to try to loft it from here up to here and then down to here. So that's not necessarily bad. That might be what you want to do. And again, just unfortunately, this sequence of lines needed that alignment. But in this case, that is not the way that these lines were set up to be extruded, right? So if I were to try to loft it here, we have overlaps of the surface. It's messy. It's not really doing what I want it to do. I could try, see what these other commands let it do. So the loose command in this case, again, it's using this second line as a kind of loose reference point to pull the surface up and then back down. The The tight one is going to try to hit every point on each line, and it's just kind of a mess. So the order of operations that you're choosing the line in is important. So another aspect of this, we can, we'll show record history in a second, but okay, so that's the basics of a loft. Obviously, you know, maybe a more architectural application of this would be, say you have a series of sections. Let's put our C-plane on the vertical here. I'm just going to hide these lines for a second. Let's say we have a series of sections that we've drawn. Maybe there's a, you know, some sort of truss situation that's getting applied to it. I'm going to use my let's just mirror those so that they're close to, not the cleanest way to do that, but you get the idea. Okay, so let's say I have some sort of truss here, and then I have a sequence of similar trusses that are creating some sort of tunnel or something down the line. So I'm going to, every 15 feet, let's say, 30 feet, 45 feet. Let's say we have 4. And then let's say this one happens, let's turn our points on. Let's say that there's some sort of bow in the middle of this that it goes up or down. So let's bring this truss with these points selected. Let's just slide this down. And again, I'm just kind of visually doing it so you can follow along a little bit more provisionally. Points on here. Let's say that this one goes up a little bit higher than its neighbor, and then ultimately ends at the same height. Let's say, though, just for one more layer of kind of complexity, let's say that this has, oops, this bows out on the side a little bit, let's say. Okay, so we have kind of these differently shaped trusses, and we'll get our C-plane back to the baseline. And now if I click Loft, and I select these in order, it should create actually, so it's going to create a closed shape because it's wanting to loft around the entire rib of the cross-section that I made. It also is asking me now about alignment, and now that I don't have just 2 shapes or 3 curves, the alignment of this is a little bit more complicated. So notice here that I have, this appears to be at the same base point in each of these, but it looks like it's migrated over one here. So if I were to loft this right now, it's probably going to twist a little bit here. Let's click Loft and see what happens. So right, we can see that because the line here is clean, but then when it gets to this point, it actually it's creating that base point one more vertex in. We actually want this line to be here so that there isn't this weird shape that gets created. Because what it did was it basically rotated everything over one bay, right? So the top that's here actually tried to rotate down to the side because our alignment was off. So if we go back to our align curves and we change this, just click this until we should be able to move it. I suppose that will do. Actually, that's still not working the right way. What I want is to get it over to this point. So we could either, well, there's a couple ways that we could do this, I guess. We could rebuild this so that each of the lines have basically the same number of control points in the same relative locations. For the sake of what I'm going to do right now, I'm just going to delete this for the moment just to complete the command in a simple way so we can see it all work. All right, so we have these 4 trusses, a little simpler. Let's loft. Let's select these in order. can see that our alignment is cooperating a little bit more. And now if I click OK, it is smoothly extruding a surface that has, again, kind of an inside and an outside through each of those cross sections, right? I could also, this is where the straight sections one might come in handy, because in fact maybe it wants to be expressed as a series of discrete bays that are straight between each of those cross sections. The tight command, again, going to be similar to normal, I think, in this case. Loose is going to be much less dramatic. And then developable in this case is actually a little confused, because what it's trying to do is create a series of surfaces that you could take and, in theory, flatten and rebuild in out of paper or out of a real life material. So we'll return to developable surfaces and printable surfaces at a future class, because that will inform some of your model making as we get further into the semester. But for now, let's just say normal. So there's your kind of extruded surface. Yes, question.
Like, how does it work with the poly surfaces when you do straight edges?
How does it work with them?
Yeah, like, 'cause it seems like it's giving me two surfaces.
All right, so let's give it a try. So basically, we're lofting. You do the straight edges, and you're saying that each of these are their own separate surface.
Yeah.
Yeah. So, well, in this case, it looks like mine. So is yours, when you're selecting it, is actually they're separate pieces?
Pretty much.
So it will be contingent.
Not separate, but like it's a poly surface.
Okay, so one aspect that's important is the baseline work. The loft will should mimic the baseline work. So if the baseline work isn't joined, it may create the loft as more segmented. So these are all like closed shapes, and I think that helped inform it. Without seeing your screen specifically.
I got basically exactly what you got.
Okay, what's your issue with that? You want to be able to troubleshoot that how?
I'm just curious, like, that's just what happens when you do that?
Yeah. So if there's a closed shape and we do use straight sections, we could go back and simplify the surface, but it will create a poly surface that tries to cover all of those points inside and outside. We could cap this thing because it has clean edges, right? So that like we looked at before, those naked openings on each side were coplanar. So the cap command will close that just fine. So this shape, for example, we could 3D print this shape if we wanted to. It's watertight. This could be printed. We could also, given that this is a little bit inefficient of a surface edge here, in that it's 3 surfaces rather than 1, because they're all coplanar. We could simplify the surface, the poly surface, by there's a couple different commands for this, but basically, because this is already all joined together, you can merge all faces. That's a command. So basically what this will do is create now, you can see the difference here. What existed before was, if I were to explode this, for example, there's 1 surface, 2, 3, right? And the same goes inside. It's basically using exactly those framework thresholds that each set of lines created. But because these are technically coplanar, this could be 1 surface that's just smooth, that doesn't have these breaks. And the way that we would do that is, let me unexplode this real quick. We can merge all faces. And then basically what that's done is let me turn our ISO curves off too. So now you can see it's just a cleaner shape. Hopefully that speaks a little bit to what your question was. You can still simplify the surface after it's been made. If I hide these cross sections, just real quick, I'm going to group them and hide them. So now that's 1 surface versus the 3 that it was before. It was seamed at where the cross sections were. And it looks like it's still, because the when I was adjusting the points on the inside, this line obviously is slightly askew of this line, so each of these actually are a different surface, technically. So
Just anywhere there's like a hard.
anywhere there's a hard change, it's going to add a seam, basically. Yep. So right. So the reason why we were able to simplify this outer surface is because even though there were lines that it used to create 3 separate ones, they're all coplanar. So whenever there's not coplanarity, it will create separate surfaces, basically. Does that make sense to everybody? So I'm just going to move this out of the way as well. Maybe we re-show our... Actually, you know what? Let's re-show our truss lines. We can do some more interesting stuff with this for a second. All right, so I'm going to ungroup these. I'm going to simplify this down to 3. Okay, so another thing that is kind of interesting with any of these commands, and this is just a taste, I guess, for some Grasshopper work further down the line, but record history is a feature at the bottom here. Let's just turn that on. So what record history is essentially, it's a precursor to what Grasshopper, what eventually became Grasshopper. So record history behind the scenes of our normal visual interface here is keeping track in a more organized way of the commands that I'm applying to the geometry that I'm looking at. So, and it will dynamically respond to changes that I make to that geometry in the scene. So for example, let's loft this again with 3 curves. So we have this, fine if it's straight sections, that's fine for now. Click OK. Okay, so what we know though about this is that, I'm just going to turn the ISO curves off. What we know about this is that this is obviously this is referencing those 3 cross-sectional curves, right? So those curves have specific data in space, that locational data in space that the shape is getting created off of, right? So if I were to remove one of these, relocate one of these, I'm just going to slide it manually. It's going to update the loft so that it's following the new location of where I moved the shape to. So that's going to be true for any of these. I could move this, again, it's anywhere in space that I want to move this, it should update. So obviously, I think you guys can see the potential in that. Quick updates to a shape, to the location of a shape. If you destroy the integrity of that shape, or you delete a component of that shape, it will break the record history moment, and it won't continue to update it dynamically. And that will be true in Grasshopper as well. If you break certain layers of the input data in Grasshopper, it'll basically give you an error saying, oh, I can't complete the path because I'm now missing data that I thought was there. So if I were to delete this, for example, delete this curve, I believe that me moving this around, it's now broken the record history because it's lacking the data points throughout to do the full loft. So it's just a quick example of record history. It's a very cool command that is, or a very cool function of RHINO that became much more robust in Grasshopper. So I think for right now, you can toy around with that on your own time if you want to. Test maybe some object creation, whether it's related to your building precedent or kind of just in a vacuum, using that record history and when it breaks and when it doesn't. But good to understand kind of the theoretical basis for what Grasshopper is, basically. So I'm just going to turn that back off for now, and I'll delete this. So another thing that we can do is,
if you want to use the record history, pull that script up and if you make a Grasshopper script,
yeah, you could use that to inform. That's a good question, and we should walk through. I'll have to remind myself how to do that. It's been a little while, but yes, because it is logging all of that data in a more kind of programming related way, it would be easier to, in theory, input it into the Grasshopper layout. So We'll take a look at that later on. So a couple other surface commands here real quick here. As it always seems like I'm talking for 5 minutes and it's an hour. How's everybody doing? Good for the moment? Okay. Awake? Not bored yet? Okay. Well, don't answer that question. So another surface creation command that I think is very powerful. Again, you can use cross-sectional curves. You can use we can use the curves that we had made before, but just to illustrate this example here, is sweep. So sweep adds kind of another layer of dynamism to a surface that you're creating. So loft is taking kind of the simplest set of data between each frame that you've created or each line that you've created, and it's finding the simplest path to extruding that data. A sweep will actually use basically two or even three sets of data to create potentially more dynamic shape. So let's, for example, say that we want to extrude between these shapes, but we want there to be additional curvature to the work in the middle. We want a cross-section that changes across extrusion from one shape to the next one. So let's say that I create a line that is kind of inverted here, almost like a tent structure that's like shrunk wrapped to the frame. So if I were to type sweep 1 to start, what this is going to do, select the rail. So what it's asking me to do is say, okay, I'm going to take a line or a profile, and I'm going to run that profile around a base shape. So the rail is the base shape that it will basically pull itself around. So in this particular case, I'm going to choose this as my rail. And then it's asking for cross-sectional curves that will create the new shape. So in this case, I just have one. I'm going to click this guy, and then I'll click Enter. And what this has done is completely mess up. Let's see if we can find, I think I was a little too big for my britches here. Let's simplify the cross-section just very briefly so we can understand what's happening. So I'm just going to explode these. I'm going to just hide the kind of internal data. Okay. Or separate the internal data at least. Let's just hide that for now. Okay. So sweep 1, select rail, select cross-section, and then it basically makes a curve that has the profile of that curve, or rather a surface, that then also follows the cross-sectional or the rail shape of the baseline, right? So again, can be very useful in starting to add some realism to physical structures, construction details, actual more complex geometries in your models. Sweep 2, as you might guess, all it does is it just asks for 2 rails rather than 1, so you can be even more controlled with it. In this particular case, this is a simple series of, it's 2 shapes that are very similar, and the line here is doing most of the work for us, but let's just show it. Sweep 2. So it's going to ask me for my first rail, it's going to ask me for my second rail, and then it asks me for cross-sections. And in this particular case, it's actually making sure that it keeps that line kind of completely attached to both sides of the line. And you can see there's some wonkiness to it, and that's just the nature of how inflected this curve is in comparison to how close these lines are. If I were to move these lines a little bit further apart or make this line shallower, then that sweep would probably be a little bit more successful. Another aspect of this that we could do is, let's say that we had a cross-section on this side that was a little bit different than the cross-section on the first side. And maybe even we have something that, well, let's just start there. So let's say sweep 2, select first rail, select second rail. Now I can select multiple cross-section curves. I was just selecting one, but if I select this other one here and then click OK, it actually, over the course of that surface, it's extrapolating the move from this one inflection curve to a double inflection curve. So
with the sweep 2, when you had the internal geometry that you hid there, would it work
I believe it should if we have the right tolerances set up. So was what I want to be able, what I think it was doing was actually running into itself because this was too far in field. Yes?
Would it work if there's like a turn and an angle?
It does. So in what particular context are you describing?
Because I tried it.
What building detail are you thinking of?
Handrails,
Uh-huh.
and I was like, yes, this will sweep it. Like, it will successfully sweep it, but when I did it, it just like
It went all over the place. Yeah. So let's do an example of that. So let's say we have some steps here. I'm just going to make these. Yes, that's absolutely the way to do it in RHINO. It is a little bit. You just have to be specific with your input. So I'm going to say 11. I'm going to say 7. Normal stair. Get a couple steps here. And then let's even say that there's, well, okay, let's start simple. So let's say that I have a rail that goes from, it's at the angle of the lines here. Let's move it up into space, 42 inches. And then I'll even draw a little, oops. All my hotkeys are not in this computer, so it looks clumsy. So let's say I have a profile for a rail here that I want to draw. So one thing that I could do, one command, just very briefly here regarding handrails, you can pipe this. That's one command. So that's just going to create a circle around the cross section that I've made, right? That's a type of sweep, but it's just with a circle. So it's a simple input. In this case, it asks me to, where do I want to create the curve around? This one. And then it's showing me a radius that I can apply to the beginning and the end of it. Let's just say the diameter of this. I can change it from diameter or radius by just typing in D. Let's say it's 1.5 inches. Let's say it's 1.5 inches at the bottom as well. So you should be able to, once you put in your beginning diameter, it will default the end diameter to the same unless you decide you want it to be different. So if I just click either enter or spacebar, it'll go for the next part of the command, which is to say, all right, at the beginning of this and at the end of this, I'm going to essentially sweep a line that is the profile of that circle. So I'll click OK, and it's created for me a piped rail that is all connected in good quality geometry. So if we up the complications of that, one thing here, let's say we'll get to the sweep, the complicated sweep profile in a second. Let's say that the radius of the curve on the edges here is 6 inches rather than this sharp edge, just to give it just a little bit smoother. So we pipe this. That's a little bit cleaner. So there's a pipe command. So let's say that we have our profile of this is something, say, let's in plan draw let's say there's some kind of underplate and then it turns into something more detailed. Who knows? Some handrail-like shape. Let's position that in place. Let's get a base point maybe somewhere along it and connect that to your line that you want to use as the rail. So if we sweep this right now, what it's going to do, what it should do, sweep 1, select rail, select cross-section curve. It should let this go all the way around using that profile. So I click OK, and it's created 3 separate shapes that all line up that follow that line. So were you having issues where it's like going off crazy?
Well, it's like going up, but it turns, but in an angle.
So let's complicate this a little bit. Let's say we have a turn in the stair, or it could be a spiral stair, whatever you might be drawing. I think you're drawing a spiral stair. But let's see.
So use there.
What's that?
Use there.
Oh, okay. For the sake of this, let's just get some curvature on this that will be kind of complicated for this to understand. I'm just going to move this out of the way for a second. So let's say we have our, I'm just going to explode this a second. Let's say we have our 42-inch marker point also up here on these steps and going up there. So I could draw, again, just for the sake of understanding how this extrudes right now, I'm going to draw a curve through these points, kind of curving my way up. It's a little bit loose, but you get the idea. So let's say we want to get this to extrude the way that you were describing. Because we've started to twist those points, I think what's going to happen is what you were encountering, where it twists on itself. So let's try to troubleshoot that. All right, so I'm going to say sweep 1. I'm going to say select rail. I'm selecting this curve. Now I'm going to select this cross section. And you're right, it angled it, right? Which is not what you wanted. So what you actually have to do is you need to give RHINO another exactly. So you need to the easiest way to do it would be to just have this same oriented curve up at the top. Just rotate it into place. So now if we sweep it, it should behave a little bit better. Select rail, select cross sections. You can control to deselect an accidental cross section curve. So now if you do that, also pay attention to where that seam alignment situation is. Kind of like before with our loft, I can click this and I can rotate it around the railing to make sure that these are more or less lining up with one another, because what it's going to do is it's going to create the extrusion around those points, so it might try to twist. So this should have done a little bit better of a job of keeping that intact. It still looks like it's twisting in that middle point. So basically what you'd want to do there is a sweep 2 would probably be a better way to do it. You'd create kind of a top line and a bottom line that it follows, and then you just have to add in just the right amount of cross section so that it keeps itself straight. But that's basically, it's needing more information to complete the task, if that makes sense.
After you did divide the curve just to make it like a perfect curve, because it doesn't make it a perfect curve, like some sticks out.
Some sticks out when you've done the sweep?
Yeah.
Okay. In some cases, that's going to be because the turn that it's trying to make is too tight for the radius of the curve that you've made. So it's trying to say, all right, I have this complicated extrusion that doesn't have edges. You're trying to, with one curve, have it turn, and it's not, the tolerance is too much. So you need to be mindful of a lot of factors there. But so sweep 2 with the right amount of guides should more closely solve that. Hopefully that was helpful. Does everybody understand? I mean, the concept of the sweep is fairly straightforward. There's a lot of ways, again, to kind of utilize it in a dynamic way, in the model. I'm just going to delete the stairs here. And yeah, in answer to the original question, could we, in theory, have this sweep around the entire thing? We could, and we just have to make sure that the tolerances were right for it. Obviously, this can work. This can work with a much more complex shape, or a busier shape at least, maybe not more complex. And this also might be close to struggling, but let's see what happens. Sweep 2. So right, and it's maintain height. So there's things within this that allows you to control how it's sweeping. It's not being particularly cooperative right now, in part because I think I'm just giving it too many variables to have to deal with. But I think you get the idea with it. So another another surface creation command that is useful is, well, there's a couple. So network surface is a good one. If you're able to have the sort of full boundary of the surface that you're making, let's just draw some more curves here. So as opposed to loft or even sweep, which just requires different types of data to be input to understand what's going on, network curve will make, with the right baseline data, it will make a lot of good assumptions about how to make the surface that you're talking about. So let's say, move that there. And then let's say that there's, some curves on the side that are doing something crazy like this. Okay, so we have this kind of weird, like melting shape going on, whatever this is. So if I were to try to loft this, it's not going to let me in an accurate way, right? It's aligning the curves, fine. It's not understanding that I want this information as well as the top and the bottom information. I could sweep this like we did, and it probably would do okay. Sweep 2, select first rail, select second rail, select cross sections. It does a pretty good job, actually. That's nice. A potentially, in general, even more accurate way of building the surface is the network surface command. So this is saying, all right, select curves in the network that you want me to turn into this surface. So in this case, I have 4, kind of defining this boundary. So this generally won't work unless you have a closed shape that it can extrapolate, basically. So 4 curves, click spacebar, and it's giving me kind of the edge curves and the tolerances that are associated with it. So A, B, C, D in the order that I selected them. If I click OK, it has created a much higher resolution surface in terms of the ISO curves, which just means that there's that many more control points that the lines are going through. The level of accuracy is even higher, let's say, than the sweep that we just did. So a network surface is, again, it's just depends on the operation that you're performing, but that tends to be the most accurate surface creation that has the most control points. But it also won't work with the same level of consistency, say, that a sweep or a loft. So let's say there's another one here. We can use the same set of curves. The patch command, which, again, I showed these in the surface tutorial. But so patch is interesting. Patch makes some bigger guesses about what it wants, what you want from it. It's less accurate than the other surface creation commands, but sometimes it's very useful to literally patch a space. Say you're creating a landscape or a model that you want to print, and there's a weirdly shaped opening or hole in the surface that you've made. A patch will try to figure out the easiest way to span that hole, even if it requires double curvature or doesn't have enough inputs. It will try to create a surface that fits that window. So let's try to patch. Let's actually select these curves and then we'll patch. So that one worked pretty well. You can see that along the edges, it's not actually connecting to all the lines, really. I could, if I patch this and I increase the spans, it'll help a little bit. But it's still not, that's closer, but it's still not to the same level of accuracy as, say, our network surface command. Let me see if I can patch something that's a little bit more complicated to illustrate the point of where it maybe doesn't do as well. So I've drawn this flat shape. Let's copy this up. So another thing we'll show in a minute So let's say that we're creating a sort of like a mushroom capped shape. So I want a surface that will go through this shape and this shape, but also close itself. Let's see if this will work. Okay, so I could obviously loft this. I could, if I created a cross section, I could attempt to sweep it. I could just make sure that my cross section is going through perpendicular points on this. But then again, it's gonna sweep the thing based on the cross section curve. So it's kind of ignoring what's happening in this one. It would only be relating to this. So if I swept this right now, it's also, because that curve is wide, it's like inverting on itself a little bit. So the patch command, if we try it here, let's see what happens. So notice patch is confused. It's trying to get through all these points that I gave it, but the nature of the points is different enough that it's not going to do a good job closing the shape the way that we want it. We could adjust the spans, or we could adjust the stiffness to give it a little bit less. So the higher the stiffness number, I believe the less, basically the stiffer the material is. So it'd be like bending a piece of metal into place. The higher the stiffness on the patch, the less it's going to pull itself to the points. So 1 would be the kind of the most porous. But again, clearly it's not really doing what we want it to do. So patch has its uses. Question, yeah.
Can you go back
Mm-hmm.
to the patch? How would you
Let me just repatch it here, sorry. How would I what?
how would you like trim off the excess stuff in the
Right, so in this particular case, it'd be tough to do. Depending on, I mean, this is such a weirdly complicated shape that clearly didn't do what it was supposed to do. You could extrude a curve and just trim around, like what's inside of it. Obviously, it hasn't achieved the shape that we wanted it to achieve already, but select cutting objects, select object to split. So I could get rid of that part, and then basically what's left over is only what was in the boundary of that extruded shape. Say that we had a simpler extrusion for it. Say it was
But what about what about like the flat stuff?
the flat stuff here,
What?
like the flat stuff over here.
Yeah.
Yeah, I mean it's the same. It's going to be the same command as if I extruded a shape. I could go into plan, check out where it actually is here, and let's say we want to fit that to, I don't know, a site plan or a topography that we've made. You could draw a curve kind of through that area and then extrude that curve up, right? So there's a series of like minimal or basic commands that would allow you to delete that. So again, I think generally the split or the trim command would probably be the best way to do it. So after, say you did use patch and it was fairly successful in creating, say, a landscape or something, but it has these weird twisted edges like you're talking about. In plan, I would go and maybe you draw a box so it at least is something regular. And then the viewport of that box, after you've extruded it, you can trim it. Okay.